consist of individual blocks made from concrete or other materials, laid out in interlocking patterns. But why choose paver blocks instead of other materials? Let's delve into the reasons behind this choice and the science that makes paver blocks so effective. 1. Durability and strength. Paver blocks are exceptionally durable and can withstand heavy loads without cracking. Unlike asphalt or concrete surfaces, which may develop potholes or fissures under stress, paver blocks distribute loads evenly. This makes them an ideal choice for areas with high traffic or heavy vehicles, such as industrial zones or parking lots. 2. Easy maintenance and replacement. One of the biggest advantages of paver block roads is their ease of maintenance. If a section of the road becomes damaged or needs access to underground utilities, individual blocks can be removed and replaced without disturbing the entire road. This minimizes repair costs and ensures quick restoration, making paver blocks a practical choice for urban infrastructure. 3. Flexibility in design. Paver blocks offer unparalleled flexibility in design and aesthetics. They come in a wide range of shapes, sizes, colors, and patterns, allowing engineers and architects to create visually appealing surfaces. This makes them particularly popular for walkways, plazas, and residential areas where aesthetics are as important as functionality. 4. Better drainage solutions. Paver block roads are excellent for managing water drainage. Unlike impermeable surfaces like asphalt or concrete, the gaps between paver blocks allow water to seep into the ground. This reduces waterlogging and prevents surface runoff, which is especially beneficial in areas prone to heavy rainfall or flooding. Some paver block systems even incorporate permeable materials to enhance water infiltration and reduce strain on drainage systems. 5. Eco-friendliness and sustainability. Many paver blocks are made from recycled materials, contributing to sustainable construction practices. Additionally, their ability to reduce water runoff helps in recharging groundwater levels, making them an eco-friendly choice. The modular nature of paver block roads also reduces waste during construction, as blocks can be reused or repurposed if needed. 6. Cost-effectiveness. While the initial cost of constructing a paver block road may be slightly asphalt or concrete roads, their long-term cost-effectiveness is undeniable. Their durability reduces the need for frequent repairs. Replace individual blocks minimizes maintenance expenses. For projects with tight budgets but long-term goals, paver blocks provide a smart investment. Adaptability to various conditions. Paver block roads can be constructed in a variety of terrains and climates. Their interlocking design allows them to accommodate ground movement without cracking, making them suitable for earthquake-prone regions. Additionally, they perform well in areas with extreme temperature variations, as they are less susceptible to thermal expansion and contraction compared to asphalt or concrete surfaces. Conclusion: the versatile choice for modern roads. Paver block roads are more than just a practical alternative. They're a versatile solution for modern infrastructure needs. With their durability, aesthetic appeal, and eco-friendliness, paver blocks are paving the way for smarter and more sustainable road construction. Thank you for watching Blueprint to Reality. If you enjoyed this journey into the world of paver block roads, don't forget to like this video, share it with your friends, and subscribe to our channel for more engineering insights. Until next time, keep exploring the wonders of civil and structural engineering.
The importance of road user behavior studies. Welcome to Reality, your hub for understanding the fascinating world of civil engineering. Today, we're exploring a crucial but often overlooked the importance of road user behavior studies. Understanding how with roads, vehicles, and infrastructure is key to designing safer, more efficient transportation systems. Understand user behavior. Road user behavior and decisions of drivers, cyclists, pedestrians, and other road users. Factors like speed choice, reaction time, distraction, and adherence to traffic rules directly affect safety. Studying these behaviors allows engineers to predict how people interact with traffic systems, enabling them to design roads that minimize accidents and congestion. The psychology of driving. Drivers' decisions are influenced by their emotions, stress levels, and even social norms. For instance, frustration in traffic jams can lead to aggressive driving, increasing the risk of collisions. Road user behavior studies delve into psychological factors, providing insights to create environments that encourage calm, rule-abiding behavior, such as or reducing visual clutter. Pedestrian and cyclist dynamics. Not all road users are behind the wheel. Pedestrians and cyclists have unique needs and vulnerabilities. Understanding their behavior, such as crossing habits and preferred paths, helps engineers design features like safer crosswalks, bike lanes, and pedestrian-only zones. Studies show that infrastructure catering to these groups reduces accidents and promotes sustainable transport options. Cultural and road use. Road user behavior varies significantly across regions and cultures. For example, lane discipline might be stricter in some areas. Engineers must account for these differences when implementing universal safety measures, ensuring local driving norms and behaviors. The influence of technology. Modern technology behavior. Features like GPS, driver assistance systems, and even mobile phones alter how people navigate and respond to traffic conditions. Studies help engineers adapt infrastructure for these changes, such as adding dedicated lanes for autonomous vehicles or stricter rules for phone use while driving. Mitigating human errors. Human error contributes to over 90% of road accidents. Studies focusing on behavior help identify common errors, such as failing to check blind spots or running red lights. Solutions like rumble strips, traffic signal countdowns, and better road markings are direct results of these studies, reducing opportunities for mistakes. Impact on safety campaigns. Behavior studies also guide public safety campaigns. Knowing why people speed while driving informs the development of targeted campaigns to change risky behaviors. These campaigns, combined with enforcement, encourage safer practices among road users. Designing roads for human behavior. Road user behavior studies bridge the gap between theoretical designs and real-world application. Engineers use this knowledge to simulate traffic scenarios, test designs, and create roads that accommodate the unpredictability of human behavior. Thank you for joining us on this exploration of road user behavior studies. If you found this video insightful, please like, subscribe, and hit the bell icon to stay updated on all things civil engineering. Let's turn every blueprint into a reality together. See you in the next video.
Understanding road cross-sections. Welcome to Blueprint to Reality, where we break down the principles and science behind the world of engineering and construction. If you've ever wondered how roads are designed for durability and efficiency, you're in the right place. Let's explore today's topic. What is a road cross-section? A road cross-section is a view of a road structure, layers and components from the surface down. It provides engineers with a blueprint to ensure the road meets safety and functionality requirements. The cross-section typically includes 1. Carriageway, driving surface, the part of the road where vehicles travel. 2. Shoulders, the edges of the road, providing space for stopped vehicles or emergency use. 3. Subgrade, the foundation layer that supports the road. Drainage features, systems to channel water away and prevent damage. Components of a road cross-section. 1. Surface layer. This is the topmost layer, made of asphalt, concrete, or other materials. It provides a smooth driving surface and ensures skid resistance. 2. Base and subbase layers. These layers distribute the load from vehicles to the subgrade, typically made of compacted gravel or crushed stone for stability and drainage. 3. Subgrade, the native soil or ground prepared to support the road. Proper compaction and stabilization are critical to prevent uneven settling. 4. Shoulders, located on the edges of the road. These provide extra width for safety and maintenance. They also serve as a runoff area for water. 5. Drainage features, include ditches, culverts, and stormwater outlets to manage water flow. Proper drainage prevents erosion and extends the road's lifespan. 6. Median, if applicable. The space separating opposing lanes of traffic, often used for safety barriers or landscaping. Importance of road cross-sections. 1. Load distribution. The layers of a road cross-section are designed to handle heavy traffic loads without deformation. 2. Durability. Proper layering and material selection prevent cracks, potholes, and other damages caused by weather and usage. 3. Safety. Features like shoulders and medians are crucial for emergency stops and reducing collision risks. 4. Drainage efficiency. Good drainage design minimizes water pooling, which can lead to hydroplaning and structural damage. How engineers customize cross-sections. The design of a road cross-section depends on several factors. 1. Type of road. Highways have more complex cross-sections with wider lanes, medians, and advanced drainage systems compared to rural roads. 2. Traffic volume and type. Roads with heavy truck traffic require thicker base layers for additional support. 3. Climate. In areas with heavy rainfall or freezing temperatures, additional measures like impermeable layers or insulation are incorporated. 4. Topography. In hilly or mountainous areas, cross-sections are adapted to include retaining walls or slope stabilization features. Challenges. Cross-section design. Sections are meticulously planned. Challenges such as limited space, budget constraints, and varying soil conditions can complicate the process. Engineers must balance these factors to create roads that are safe, efficient, and cost-effective. Real-life example. A great example is the Golden Quadrilateral in India, where road cross-sections were meticulously planned to handle high traffic volumes and diverse weather conditions. Features like wide medians and advanced drainage systems were included to ensure longevity and safety. Conclusion. Road cross-sections might seem like a technical detail, but they form the backbone of effective road design. By understanding the components and their roles, we can better appreciate the engineering marvels that make our daily commutes possible. Thank you for watching Blueprint to Reality. If you enjoyed this breakdown of road design, don't forget to like, share, and subscribe. Hit the notification bell to stay updated with our latest videos. Until next time, keep exploring the amazing world of engineering. Understanding soil stabilization in road construction. Welcome to Blueprint to Reality, your go-to source for all things civil and structural engineering. In today's video, we'll be discussing soil stabilization and its crucial role in road construction. From enhancing soil strength to improving durability, soil stabilization is a key process for building long-lasting roads, especially in challenging terrain. Let's dive in. 1. What is stabilization? Soil stabilization is the process of improving the properties of soil to increase its strength, stability, and resistance to weathering. This is achieved by adding certain materials or chemicals to the soil, allowing it to support the weight of roads, reduce water absorption, and prevent erosion. Soil stabilization is especially important for roads constructed in areas with weak or unstable soil, such as clay, sandy, or expansive soils. 2. Why is soil stabilization important in road construction? In road construction, quality of the soil layer that supports the road structure is crucial for the stability and longevity of the pavement. Without proper stabilization, the subgrade may experience shifting, cracking, or erosion, which leads to road failure. By stabilizing the soil, engineers can create a solid foundation that can withstand traffic loads, moisture changes, and extreme weather conditions. 3. Types of soil stabilization methods. There are 2 primary types of soil stabilization: mechanical and chemical. Mechanical stabilization. This involves physically altering soil by mixing it with aggregates, such as gravel or sand, to improve its texture and strength. This method helps to create a more uniform soil structure that resists deformation under pressure. Chemical stabilization. This method uses chemical agents, such as lime, cement, or fly ash, to react with the soil and form a stronger, more durable bond. These chemicals improve the soil's load-bearing capacity, reduce plasticity, and enhance moisture resistance. Chemical stabilization is particularly effective for clay soils that tend to shrink or swell with moisture changes. 4. Common stabilizing agents and their benefits. Lime. Lime stabilization is one of the most commonly used methods, particularly for clay soils. It reacts with the soil to reduce its plasticity and improve its compaction properties. Lime stabilization also helps control the soil's moisture content and increases its strength. Cement. Cement stabilization involves mixing cement with soil to create a more rigid, wood-bearing foundation. This method is ideal for areas with poor, weak soils and is commonly used in urban road construction. Fly ash. Fly ash, a byproduct of burning coal in power plants, is a sustainable stabilizing agent that improves soil's strength and durability. It is often used in combination with lime or cement to enhance soil stabilization. Polymer additives. In some cases, polymer additives are used for stabilization, especially in areas requiring enhanced moisture resistance and flexibility. These additives can provide a high level of durability while being more environmentally friendly than traditional chemicals. 5. Benefits of soil stabilization in road construction. Soil stabilization offers several key advantages. Improved load-bearing capacity. Stabilized soil provides a stronger foundation, enabling roads to handle heavier traffic loads without deterioration. Enhanced durability. Stabilized soil is more resistant to erosion, cracking, and shifting, extending the lifespan of the road. Cost effectiveness. Stabilizing local soil reduces the need for costly imported materials, leading to savings in construction costs. Better drainage and moisture resistance. Properly stabilized soil helps reduce water infiltration, which can lead to pavement cracking and erosion. This is particularly beneficial in regions with heavy rainfall or fluctuating temperatures. 6. Challenges in soil stabilization. While soil stabilization is highly beneficial, it does come with some challenges. The cost of certain stabilizing agents, such as cement or lime, can be high, particularly in large-scale projects. Additionally, the success of soil stabilization depends on factors like soil type, moisture content, and climate conditions. In some cases, soil testing is required to determine the most effective stabilization method, which can increase project timelines. 7. Environmental considerations. The environmental impact of soil stabilization is an important consideration, especially when using chemical agents like lime or cement. Overuse of certain chemicals can lead to soil imbalances and pollution. However, advancements in eco-friendly stabilizing agents, such as bio-based polymers and recyclable materials, are helping to make soil stabilization more sustainable and environmentally friendly. 8. The future of soil stabilization. With ongoing research and technological advancements, the future of soil stabilization looks promising. New, sustainable stabilizing agents and more efficient methods of application are making soil stabilization more cost-effective and eco-friendly. Additionally, smart technologies such as soil moisture sensors and automated mixing equipment are improving the precision and efficiency of stabilization processes. These innovations will allow engineers to better design and construct roads that are both durable and environmentally responsible. Soil stabilization is a cornerstone of road construction, ensuring that roads are built on a solid, durable foundation. As technology continues to evolve, the methods used to stabilize soil will only improve, offering more sustainable solutions for the roads of the future. If you found this video helpful, don't forget to like, share, and subscribe to Blueprint to Reality. We'll be back with more insights into civil engineering. Thanks for watching. Understanding the role of traffic engineering. When you think of traffic, what comes to mind? Bumper-to-bumper jams, the endless wait at red lights, or that one roundabout that feels like chaos in motion. But have you ever stopped to wonder, who makes sense of all this? How do cities ensure we can move safely and efficiently. Today, on Blueprint Reality, we're diving into the fascinating world of traffic engineering. Traditional traffic management. For decades, traffic systems have revolved around basic tools: road signs, traffic lights, and painted lanes. They help guide vehicles, but they're just the tip of the iceberg. These systems were designed to handle simpler, less crowded roads. However, with expanding and vehicle numbers skyrocketing, traditional methods often fall short. The result? Congestion, accidents, and frustration. Enter traffic engineering, a field dedicated to solving these problems through science, data, and innovation. What makes traffic engineering special? At its core, traffic engineering is all about optimization, getting the most out of our roads while keeping everyone safe. It's not just about building bigger roads. It's about building smarter ones. Take intersections, for example. Engineers analyze data to decide whether a traffic light, a roundabout, or even an overpass is the best solution. They consider traffic flow, pedestrian safety, and even environmental impact. And it's not just cars. Traffic engineering also accounts for buses, bikes, and foot traffic. The ultimate goal? A balanced system where everyone gets to their destination quickly and safely. The role of technology. Here's where it gets really interesting. Technology is revolutionizing traffic engineering. Think of adaptive traffic lights that change in real time based on congestion, or sensors that monitor traffic flow and send instant updates to city control centers. You've probably used GPS apps like Google Maps or Waze. Did you know they rely on traffic engineering data? These apps don't just guide you. They're part of a larger, interconnected system designed to keep traffic moving efficiently. Impact on safety and environment. Now, let's talk safety. Did you know that poorly designed roads are a leading cause of accidents? Traffic engineers work to eliminate these risks by redesigning high crash areas, adding crosswalks, and even adjusting speed limits. And then there's the environment. Congestion not only wastes time, but also burns fuel, releasing harmful emissions. By reducing stop-and-go traffic and promoting public transport, traffic engineering helps cut down pollution and carbon footprints. Real-world examples. Need some real-world proof? Look at Singapore, a global leader in traffic management. With electronic road pricing and advanced traffic monitoring systems, they've turned one of the busiest cities into one of the smoothest to navigate. Or consider Amsterdam, where engineers have seamlessly integrated bike lanes into the urban layout. It's a city designed not just for cars, but for everyone. Future of traffic engineering. So what's next? The future of traffic engineering is all about going smart. Autonomous vehicles communicating with traffic systems, drones monitoring congestion from above, and AI predicting and preventing bottlenecks before they even happen. Imagine a world where traffic jams are a thing of the past. Technology and forward-thinking engineering. It's closer than you think. Traffic engineering is more than just planning roads. It's shaping how we live, work, and move in our cities. Every red light, every highway, and every crosswalk is a testament to this hidden but crucial field. So, the next time you're on the road, take a moment to appreciate the systems that keep it all moving. If you found today's topic fascinating, make sure to like, comment, and subscribe to Blueprint Reality. Until next time, safe travels. What is bitumen and how is it used in roads? When you think of roads, one material often comes to mind. Bitumen. But what exactly is bitumen, and why is it so important in road construction? This fascinating material forms the backbone of modern pavements, ensuring durability, flexibility, and cost efficiency. Today, we'll uncover the secrets of bitumen and its critical role in road engineering. What is bitumen? Bitumen is a dark, viscous material derived from crude oil during the refining process. It's essentially the residue left after extracting lighter fuels like petrol and diesel. Bitumen is known for its adhesive properties and water resistance, making it an ideal binder in road construction. This material can vary in consistency and grade, depending on its intended use. From soft grades for cold climates to harder grades for hot regions, bitumen's versatility makes it indispensable in infrastructure projects. Key properties of bitumen. 1. Adhesive strength. Bitumen binds aggregates together, creating a cohesive and durable road surface. 2. Water resistance. It prevents water infiltration, which can weaken the pavement structure. 3. Flexibility. Bitumen can withstand minor deformations caused by traffic loads and temperature changes. 4. Durability. Properly mixed bitumen ensures long-lasting pavements with minimal maintenance. How bitumen is used in roads. 1. Asphalt pavements. Bitumen is mixed with aggregates to create asphalt, the most common material for road surfaces. This mixture provides a smooth, flexible, and durable layer that can handle heavy traffic loads. 2. Surface dressing. Bitumen is sprayed onto the road surface, followed by a layer of aggregates. This method improves skid resistance and seals minor minor cracks. 3. Bituminous concrete. A more refined mix. Bituminous concrete is used for high traffic areas like highways and airports, offering superior strength and resistance to wear. 4. Cold mix asphalt. For remote areas or low traffic roads, cold mix asphalt. Bitumen mixed with aggregates at ambient temperature is a cost-effective and easy-to-apply solution. Advantages of using bitumen in roads. Cost-effective. Bitumen is relatively inexpensive compared to alternative materials like concrete. Ease of maintenance. Bitumen roads are easy to repair, allowing for quick and cost-efficient fixes. Sustainability. Bitumen is recyclable. Old asphalt can be milled, reheated, and reused, reducing waste and conserving resources. Adaptability. With proper modification, bitumen can be tailored to withstand extreme climates and heavy traffic. Challenges and innovations. Despite its advantages, bitumen faces some challenges. Temperature sensitivity. Bitumen softens in high heat and becomes brittle in extreme cold. Innovations like polymer-modified bitumen, PMB, address these issues, enhancing its temperature resilience. Environmental concerns. Being a petroleum product, bitumen's extraction and use have environmental impacts. Researchers are exploring bio-based alternatives and ways to reduce its carbon footprint. Conclusion. Bitumen is more than just a binding agent. It's the backbone of modern road infrastructure. Its unique properties and versatility make it the go-to material for pavements worldwide. By continuing to innovate and address its limitations, engineers can ensure that bitumen-based roads remain durable, sustainable, and adaptable to future challenges. Thank you for tuning in to Blueprint to Reality. If you found this exploration of bitumen's role in road construction insightful, don't forget to like, subscribe, and hit the notification bell. Share your thoughts or questions in the comments below. We'd love to hear from you. See you in the next video. What is hold in place recycling and road construction? Welcome to Blueprint to Reality. Welcome back to Blueprint to Reality, your trusted channel for uncovering the science behind civil and structural engineering. In today's video, we'll be exploring an innovative and sustainable method in road construction. Cold in place recycling, or CIR. If you're curious about how old worn-out roads are transformed into like new pavements with minimal waste and environmental impact. You're in for a treat. Don't forget to like, share, and subscribe to stay updated with more engineering insights. Introduction to cold-in-place recycling. Cold-in-place recycling is an environmentally friendly technique used to rehabilitate existing asphalt pavements. Instead of removing old asphalt and transporting it to a landfill, CIR reuses the existing materials on site. This method not only reduces construction costs and waste, but also minimizes the environmental footprint of road projects. Let's dive into the step-by-step process to understand how this remarkable method works. 1. Assessing the existing pavement. The first step in CIR is evaluating the condition of the existing road. Engineers assess the pavement's structural integrity, cracks, and other signs of wear and tear. This evaluation helps determine whether the road is a suitable candidate for CIR and identifies the specific areas that need attention. Advanced testing equipment like ground-penetrating radar or core sampling may be used to assess the pavement's thickness and composition. 2. Milling the asphalt surface. Once the road is deemed suitable for CIR, the top layer of the existing asphalt is milled using specialized equipment. Milling machines remove the damaged asphalt to a predefined depth, typically between 50 millimeters and 150 millimeters. This material is then crushed and screened to achieve the desired particle size for reuse in the recycling process. 3. Adding recycling agents. The milled asphalt is mixed with recycling agents to rejuvenate the aged materials. These agents may include emulsified asphalt, ensures roads are strong and durable. If you enjoy learning about the science behind construction, don't forget to like, share, and subscribe for insightful content. Introduction to subgrade preparation. Subgrade preparation is the first step toward creating a robust and long-lasting road. The subgrade is essentially the soil layer beneath the pavement structure that supports the entire road. If the subgrade is weak or poorly prepared, the road will fail prematurely, no matter how well the surface is constructed. In this episode, we'll explore why subgrade preparation is essential, the steps involved, and how engineers ensure its quality. 1. Important. What is super elevation in roads? Welcome to Blueprint to Reality, your destination for exploring the fascinating concepts behind civil and structural engineering. If you've ever wondered about the hidden science that shapes our roads and cities, you're in the right place. Let's dive into today's topic. What is superelevation? Superelevation is the transverse slope or tilt given to a road curve where the outer edge is raised higher than the inner edge. It's usually expressed